Right now, as you're watching this, your home is lying to you. You think those walls are protecting you. You think that insulation in your attic is your insurance policy. You think when the grid goes down, you'll just fire up your backup heater and ride it out in comfort while everyone else freezes. You're wrong, and that mistake will kill you in 3 days. Here's what's about to happen. The power grid fails. Could be tomorrow, could be next winter. Doesn't matter. Your furnace stops, and in the next 72 hours, your modern, well-insulated home will transform into something you didn't see coming. A refrigerator. A giant, inescapable refrigerator with you trapped inside. And here's the part that's going to make you question everything you thought you knew about survival. The better your home is insulated, the worse this problem becomes. That's right, your expensive insulation isn't going to save you. It's going to trap you in a thermal death spiral. I'm going to show you something that 99% of preppers have completely wrong. It's not about stockpiling more fuel. It's not about buying a bigger heater. It's about understanding one brutal law of physics that your home is actively using against you right now. And the truly terrifying part, most people don't figure this out until they've already wasted their entire fuel supply, until they're sitting in a 40-degree house burning through their last propane tank, wondering why nothing is working. By then, it's too late. This isn't theory, this isn't speculation. People die from this exact failure mode every single winter, inside their homes, inside insulated, modern structures, while their neighbors wonder how someone could freeze to death indoors. You've got one chance to understand this before it matters. One chance to rewire your entire survival strategy before the crisis forces you to learn it the hard way. So here's the question that should be keeping you up at night. When your home drops to 40 degrees and your backup heater is running and you're still freezing, will you know what to do? Or will you keep making the same fatal mistake everyone else makes? Because I'm about to tell you something that architects don't want you to know, something HVAC engineers quietly understand but never explain, something that changes everything about how you need to prepare. Your home is not a shelter, it's a thermal battery, and when the power dies, that battery is going to charge itself with cold. Let me show you how it kills you, and more importantly, how to survive it. The obvious problem and why it's a lie. Let's get the basic stuff out of the way first. The grid goes down, the natural gas line goes cold. Your HVAC system, that beautiful, expensive furnace hiding in your basement, stops pumping heated air through your ducts. That's the trigger event. We all know this. That's not the flaw. The flaw is what happens in the next 72 hours. Why does a 70-degree home drop to 40 degrees and then just stay there? Why does your house resist every attempt to warm it back up? Why does it actually feel colder inside your insulated, protected structure than it does standing outside in the open air? You're about to find out, and once you see it, you'll never look at your home the same way again.
The thermal battery, your home's death sentence. Here is the truth that will rewrite everything you think you know about shelter. Your home is not a thermos. Your home is a thermal battery. And right now, while you're reading this, that battery is being charged. Your furnace is running. It's pumping heat into the drywall, into the wood studs, into the concrete foundation, into every piece of furniture, every cabinet, every square inch of flooring. Your entire house is a massive thermal storage system, and it's constantly being fed energy to maintain temperature equilibrium. This is how modern homes work. This is why they feel comfortable. The mass of your structure holds the heat. The insulation slows the discharge rate. Your furnace tops it off every 20 minutes. It's a closed-loop system, and it works beautifully. Until it doesn't. When the power cuts, that battery starts to discharge. The heat begins leaching out through every surface, every joint, every microscopic gap. Your insulation slows this process, sure. That's what it's designed to do. But here's the critical part everyone misses. Insulation doesn't stop heat loss. It only slows it. After 24 hours, your house is at 60 degrees. After 48 hours, it's at 50. After 72 hours, you're looking at 40 degrees, maybe lower depending on your climate. And here, right here, is where the hidden flaw becomes lethal. Once your house reaches equilibrium with the outside temperature, your insulation stops being your friend. It doesn't just keep the cold out anymore, it now perfectly, efficiently traps the cold in. Your home has become a giant, high-performance refrigerator, and you're living inside it.
The refrigerator effect, when protection becomes prism. Think about your actual refrigerator for a second. What makes it work? Insulation. thick, dense insulation that prevents thermal transfer. When the compressor is running, it maintains the cold. When the compressor stops, that insulation keeps the interior cold for hours, even days. The insulation doesn't care about temperature direction. It just resists change. Your home operates on the exact same principle. While the furnace was running, that insulation was helping maintain warmth by slowing heat escape. Now that the house is cold, that same insulation is maintaining the cold by preventing heat entry. You've essentially been living inside a reverse thermos, and you didn't even know it. This is the thermal battery, charged to freezing. And now every molecule of drywall, every 2x4 stud, every piece of plywood subflooring is working against you. They're all heat sinks, cold sinks. They're all pulling thermal energy away from anything warmer that comes into contact with them, including you. You sit on your couch and it feels like ice, because it is ice. Not frozen, but charged to 40 degrees. Your bed, your carpet, your walls, everything is a giant thermal mass set to refrigeration temperature. And your body, sitting at 98.6 degrees, is constantly radiating heat into this massive cold sink. This is why people freeze to death inside insulated structures. This is why hypothermia happens indoors. The environment isn't just cold, it's actively pulling heat away from you faster than your body can produce it. And it gets worse.
The compounding failure, while your backup plan is worthless. So you're prepared, right? You've got your backup heating solution. Maybe it's a propane heater, maybe it's a kerosene heater. Maybe you're planning to run a wood stove or a generator-powered space heater. You've done the math. You've calculated BTUs. You think you're ready. You're not. Because you're not just heating air, you're fighting thousands of pounds of 40-degree thermal mass. Every wall, every floor, every piece of furniture. They're all heat vampires, and they will drain your small heater faster than you can possibly imagine. Let's do the brutal math. A typical American home has about 2,000 square feet of living space. Let's say your drywall, studs, flooring, and furniture collectively weigh around 50,000 pounds. That's a conservative estimate. Now that mass is sitting at 40 degrees. You need to raise it back to 65 degrees just to feel comfortable. That's a 25-degree temperature increase across 50,000 pounds of material. The specific heat capacity of drywall is about 0.26 BTUs per pound per degree. Wood is similar. Do the math, and you're looking at over 300,000 BTUs just to warm the structure itself. Not the air, the structure. Your little propane heater is putting out maybe 9,000 BTUs per hour. You're looking at over 30 hours of continuous burning just to begin warming the mass. And that's assuming zero heat loss during that time, which is physically impossible. You will burn through your entire fuel supply trying to heat the house, and the house will stay at 40 degrees. The American home design flaw, built for centralized power. This problem is uniquely catastrophic in modern American construction. Why? Because these homes were never designed to be heated by a small, localized source. They were engineered for one thing, a powerful, centralized HVAC system that forces heated air into every corner of the structure through a pressurized duct network. That beautiful open concept floor plan, that vaulted ceiling in your living room, that's not a feature in a grid-down scenario, that's a thermal nightmare. You're looking at an impossible volume of air to heat with a single small device. The warm air rises immediately, the cold air pools at ground level, and that cold mass of walls and floors keeps pulling the heat away from you. European homes, particularly older brick and stone construction, face the same problem but worse. Stone has an even higher thermal mass than drywall. Those thick walls that kept castles cool in summer and warm in winter, they worked because there were massive fireplaces in every room, constantly burning, constantly feeding heat into the stone. Once those walls go cold, they will suck heat away from you for weeks. The principle is identical. Your backup heater creates a 5-foot bubble of warmth around itself. You huddle there, you burn through your fuel, and the house remains at 40 degrees. This is the downward spiral. You're fighting a battle against basic thermodynamics, and thermodynamics always wins. Always. The only solution? Abandon the house without leaving it. Here's the counterintuitive strategy that will save your life. Stop trying to heat your house. You heard me. Abandon the entire concept. Because if you try to heat your 2,000 square foot structure with limited fuel and a small heat source, you will fail. You will waste your resources, and you will still be dangerously cold.
The solution is to abandon the house as a living space while still using it as a wind and weather barrier. You are no longer heating a structure, you're creating a microclimate. This is the survival strategy that actually works. This is what people who live through grid-down winters figure out, usually after they've already wasted half their fuel supply trying to do it the wrong way. You're going to choose one small room, not the living room, not the master bedroom, a small interior space, a walk-in closet, a bathroom, a small bedroom with minimal exterior wall contact. The smaller, the better. Ideally, this room is surrounded by other rooms, creating a buffer zone between you and the outside walls. This is now your entire living space. This is where you sleep, eat, and exist until power returns or spring arrives. Building your microclimate, the only plan that works. Here's how you execute this strategy. Rule 1. Isolate your space. Seal off your chosen room from the rest of the house. Close the door. If there's a gap under the door, stuff it with towels or clothes. You want to minimize air exchange with the larger cold mass of the house. The rest of your home is now just an outer shell, a wind barrier, nothing more. Rule 2. Insulate internally. This is the critical step everyone misses. Your home's insulation is in the walls and attic, which means it's protecting the cold thermal mass, not you. You need to create a new thermal barrier inside your microclimate. Hang blankets, sleeping bags, tarps, or plastic sheeting on the inside surfaces of your room's walls. Yes, over your nice drywall. You're creating a dead air space between the cold wall mass and your living space. This is the same principle as a tent. The fabric itself provides minimal insulation. The trapped air layer does the work. Cover the ceiling if you can too. Heat rises. You want to trap it in your microclimate, not let it escape into the attic or the rest of the house. Hang a heavy blanket or tarp over the doorway, not just closing the door, actually create a fabric barrier. This is your airlock. Every time you enter or leave, you're minimizing the cold air intrusion. Rule 3, heat the person, not the volume. Now and only now you deploy your backup heat source. A small propane heater, a candle lantern, even just your own body heat. You're no longer trying to heat 50,000 pounds of structure. You're heating maybe 100 cubic feet of air and a few hundred pounds of material in your immediate space. This changes everything. Your 9,000 BTU heater that was completely inadequate for the whole house is now massively overpowered for your microclimate. You may only need to run it for 30 minutes every few hours. Your fuel supply that would have lasted 3 days trying to heat the whole house now lasts 3 weeks. The walls of your microclimate are still cold. The floor is still cold, but they're on the other side of your fabric barrier. They're not in direct contact with you. You're living in a warm air pocket, insulated from the cold mass by layers of dead airspace. This is how humans survived before central heating. This is how people in extreme climates still live today. Small, super insulated spaces, minimal volume, maximum efficiency.
The psychological trap. Your mind will fight this strategy. Here's the hard part. Your brain will resist this strategy. You'll look at your beautiful home and think, I can't just abandon it. I can't live in a closet. I spent a fortune on this house. There has to be another way. There isn't. Your emotional attachment to your home as a living space is a cognitive bias that will kill you. The house is a structure, a weather barrier. It's keeping the wind and precipitation off you. That's valuable, but trying to maintain it as a heated living space with limited resources is a fatal mistake. People die every winter in grid-down situations because they refuse to accept this reality. They keep trying to heat the whole house. They burn through their fuel in days, and then they're stuck in a 40-degree structure with no backup plan and no remaining resources. Don't be that person. The second-order problems. What happens next? Let's say you've set up your microclimate. You're warm, you've conserved fuel. Congratulations, you've solved the primary problem. But you're not done. Problem: food storage. Your main house is now at 40 degrees. That's actually perfect for food storage. Your refrigerator is useless without power, but your house is now a giant refrigerator. Perishables that would spoil in hours at room temperature will last weeks at 40 degrees. Use it. Your microclimate is too warm for long-term food storage. Keep your supplies in the cold zone. Problem: water. Water freezes at 32 degrees. If your house drops below freezing, your pipes will burst. If you have water storage containers in the main house, they'll turn to ice. You need to move critical water supplies into your microclimate or drain your pipes completely before they freeze. This is non-negotiable. Problem: moisture and condensation. You're breathing, you're cooking, you're producing moisture. In a super insulated microclimate, that moisture has nowhere to go.
It will condense on the coldest surfaces, which is usually your fabric barriers. You need ventilation. Not a lot, just a small gap or a brief opening every few hours to let humid air escape and fresh air enter. Too much ventilation defeats the insulation, too little, and you'll have mold and respiratory problems. Problem: carbon monoxide. If you're using any combustion-based heat source, you need ventilation for safety, not just comfort. Carbon monoxide is odorless and deadly. Even a small propane heater produces it. You must have a carbon monoxide detector with working batteries, and you must crack a window or door slightly to ensure fresh air intake. Yes, this reduces your thermal efficiency. The alternative is death by CO poisoning. Choose wisely. Problem: cabin fever. Living in a 100-square-foot space for weeks or months is psychologically brutal. You'll go stir-crazy, you'll get claustrophobic, you'll be tempted to abandon the microclimate and spread back out into the cold house just for mental relief. Don't. Set up a routine. Do exercises in your space. Read. Keep your mind occupied. The discomfort is temporary. Hypothermia is permanent. The reality check. This is not a comfortable solution. Let's be brutally honest about what the survival strategy actually looks like. You're living in a closet or a bathroom. You're sleeping, eating, and existing in a space the size of a prison cell. Your entire family might be crammed into this tiny area. It's not glamorous. It's not comfortable. It's not what you imagined when you bought your house, but it works. This is the difference between survival and comfort. Survival means accepting that your normal life is over temporarily. It means making choices that feel wrong because they violate your expectations of how life should be. Your home is built for a world with unlimited cheap energy. When that energy disappears, the house doesn't just lose its comfort, it becomes actively hostile. The thermal mass that provided stability becomes a liability. The insulation that provided efficiency becomes a trap. You can't change the physics. You can only adapt your strategy to work within the constraints of reality.
The tool you need, the thermal imaging camera. If you're serious about understanding your home's thermal behavior, you need one tool, a thermal imaging camera. These devices used to cost thousands. Now you can get a smartphone attachable unit for under $300. It's worth every penny. Point it at your walls when your furnace is running. You'll see the heat radiating from the drywall. Point it at your walls 12 hours after the power cuts. You'll watch the heat leaching away. Point it at your microclimate setup. You'll see exactly where your insulation is failing and where cold air is infiltrating. This isn't speculation anymore. This is data. You can see the thermal battery charging and discharging. You can see where your heat is escaping. You can optimize your microclimate based on actual thermal imaging, not guesswork. Knowledge is survival. Ignorance is freezing to death inside your insulated home. The community factor, when it's not just you or a small family group. What if you're sheltering a larger group? What if neighbors show up? What if your microclimate suddenly needs to accommodate 8 people instead of 2? The principle doesn't change. You just need a bigger microclimate. A 10 by 10 bedroom can handle 2 people comfortably, 4 people cramped. A 12 by 12 room can handle 6 if they're desperate. You adjust the space to the group size, but you still maintain the core strategy. Isolate, insulate internally, heat the minimum volume necessary. Body heat becomes a significant factor with larger groups. 8 people in a small space are producing roughly 800 BTUs per hour just from metabolic heat. That's not enough to maintain comfort by itself, but it's a meaningful contribution. You'll need less supplemental heating with more people. The trade-off is oxygen consumption, moisture production, and interpersonal conflict in confined spaces. There's no perfect solution, only trade-offs. The long-term reality, when spring doesn't come fast enough. Let's talk about the scenario nobody wants to imagine. What if the grid doesn't come back in weeks? What if it's months? Your fuel will run out eventually. Even with perfect microclimate efficiency, you can't burn propane forever. So what's the end game? You need to transition to renewable heat. Wood, if you have access and a way to burn it safely, solar heating during daytime, even passive solar through south-facing windows if you can create a sun-warm zone and transfer that heat to your microclimate. Body heat. Composting organic material in sealed containers can generate heat through decomposition, though it's minimal and potentially hazardous if done wrong. The microclimate strategy buys you time. It extends your fuel supply by 600%, but it's not infinite. You need to be thinking about phase 2 before phase 1 runs out. This is why fuel storage calculations are critical. How much do you have? How efficiently are you using it? How long before you need an alternative? Run the math now. Don't wait until you're on your last tank to realize you needed a plan. The psychological warfare, your house versus your mind. Here's the part that nobody talks about in survival planning, the psychological battle. You're going to be living in a cold house restricted to a tiny space for an undefined period of time. Your brain is going to play tricks on you. You'll convince yourself that it's not that cold, that you can tough it out, that you should spread back into the main house because you need the space. This is cognitive bias. This is your comfort-seeking brain trying to override your survival logic. 40 degrees doesn't feel that cold when you first experience it. You think, this is manageable. But sustained exposure to 40 degrees will drop your core temperature over hours and days. You'll become hypothermic without even realizing it. Your cognitive function will decline. You'll make bad decisions. You'll stop feeling cold because your body's temperature regulation is failing. This is how people die indoors. You need objective measurements, not subjective feelings. Thermometer. Check your microclimate temperature every few hours. If it drops below 55 degrees, you need to increase heat input or improve insulation. Don't trust your body's perception, trust the data.
The hard truth, most people won't do this. I can lay out the physics. I can show you the math. I can give you the exact strategy that will keep you alive. And most people still won't implement it. Why? Because it requires accepting an uncomfortable reality. Your home is not the fortress you think it is. Your preparation isn't complete just because you have supplies. And survival in a grid-down winter requires living in a way that feels wrong, uncomfortable, and beneath your standards. People would rather cling to the illusion of normalcy than embrace the reality of adaptation. This is why survival isn't about gear. It's not about how much you stockpiled or how expensive your backup heater was. It's about your willingness to abandon your expectations and do what actually works, even when it's psychologically difficult. The preppers who survive aren't the ones with the most stuff. They're the ones with the mental flexibility to change their strategy when reality doesn't match their plan. The final punch, the choice you need to make. So here's where we are. Your home is a thermal battery. When the grid is up, it's charged with heat. When the grid goes down, it discharges into the cold. Your insulation doesn't stop this, it only slows it. And once your home reaches equilibrium with outside temperature, that same insulation traps the cold inside, turning your shelter into a refrigerator. You cannot heat the entire structure with limited fuel and a small heat source. Physics won't allow it. Trying to do so will waste your resources and leave you just as cold, but now with no backup options. The only strategy that works is to abandon the house as a living space and create a microclimate. One small room, internal insulation, minimal volume, maximum efficiency. This isn't comfortable. This isn't what you expected. This isn't the prepper fantasy of living normally while the world falls apart around you. But it's real and it works. You can accept this reality now while you still have time to plan and practice. You can set up your microclimate, test your approach, and refine your strategy before the crisis hits. Or you can cling to the illusion that your home will protect you. You can wait until the grid fails. You can waste your fuel trying to heat the whole structure. And you can learn this lesson the hard way when you're already cold, already depleted, and already out of options. The thermal battery doesn't care about your feelings. The laws of thermodynamics don't care about your expectations. And the winter doesn't care about your plans. Your home is not a shelter. It's a system. And that system is fundamentally broken without the grid. Stop planning how to heat your house. Start planning which tiny corner of it you'll actually live in. That's the plan that will keep you alive when your home becomes an icebox. The choice is yours, just don't take too long to make it. The clock's already ticking, and that thermal battery is waiting to charge itself with cold. Welcome to the new world. Stay warm or don't, but don't say nobody warned you.